We are solving now a paper 2 section A problem about finding the minimum area of a triangle formed between three lines. The first line over here is given by y is equal to 10 minus 2x. Then we have the line y equals mx in terms of a parameter m. And then the line y equals minus 1 over mx. So those two lines, there are one perpendicular to the other because one has a slope m and the other minus 1 over m. And they are both lines going through the origin. We know also that m has to be at least 1/2. So let's make a small sketch of what's going on over here, even though, well, we have a parameter, so we cannot have a precise picture, but just an idea of what's going on here. So let's say we have here x, y, and then we have the line y equals 10 minus 2x, negative slope, let's say, like this, equals 10 minus 2x. And then we have the line y equals mx, so to the origin, like this. And then the line perpendicular to it, also to the origin, so I don't know, something like this. Y equals minus 1 over mx. Okay, and the right angle is here at the origin. So this picture is good enough for us to understand what is the situation. This is the triangle we want to minimize the area. It's a right angle triangle. So if we want to write the area, that's going to be 1/2 times, let's call this side A, and this side is B, so times A times B. So we need to find the length of this segment that I call A over here, and the length of the segment that I called B over here. Excuse me. So to find the length of those segments, we're going to need to find what are the points of intersection here. Let me call them I and J. So we need to find where the lines y equals mx and y equals 10 minus 2x, where they intersect. That's a point I call I. And then the same for the lines y equals minus 1 over mx and y equals 10 minus 2x. I call this point J. So for the first one, we need mx to be the same as 10 minus 2x, which means we need mx plus 2x to be the same as 10. X is common factor, 2 plus m is equal to 10. So the value of the x coordinate of the point of intersection is 10 over 2 plus m. And then the y-intercept is going to be m multiplying this number, so 10 plus 2m. So I has coordinates 10 over 2 plus m and m 10 over 2 plus m. We repeat the same for the point of intersection of the other two lines. So minus 1 over mx is the same as 10 minus 2x. So 2x minus 1 over mx is equal to 10. X is common factor, 2 minus 1 over m has to be 10. So the x coordinate is 10 over 2 minus 1 over m. We may want to rewrite this as 10m over 2m minus 1 if we take common denominator, m in the denominator, and then we multiply by the reciprocal fraction. So y is going to be minus 1 over m multiplying this is expression 10m over 2m minus 1. So y is going to be negative 10 over 2m minus 1, or we can write this as 10 over 1 minus 2m. So the coordinates of the point of intersection J are 10m over 2m minus 1, 10 over 1 minus 2m. So now that we know the points of intersection, actually we want them because we want to find the length of the segments A and B. So let me write over here what the coordinates of I and J are, so we can make a bit of space to continue with the work. That's for I, and now for j. So the length of the segment we call A is going to be the distance between the origin O and the point I. So we need to find the square root, and 10 over 2 plus m minus 0 square plus 10m over 2 plus m minus 0 square, just using the distance formula, square root of all of this. So this is 10 over 2 plus m square plus 10m over 2 plus m also square, and then the square root of this. See if we can simplify this a little bit more. 10 square plus 10 square m square over 2 plus m, all of that square, and then we need to take the square root each in the numerator and the denominator. Luckily things cancel a bit, so 10 is multiplied by 1 plus m squared to the power of a half, and here in the denominator we have just 2 plus m. Remember that m is positive, so we have no problem here. So here for the area we have so far a half times the length of the segment A we found over here. I'm writing it again so we make more space. Times we need to also find what is the length of the segment B. For the segment B we are finding the distance between the origin and the point that we call J. So we need to do 10m over 2m minus 1, all of that square, plus 10 over 1 minus 2m, all of that square, and then the square root of all of that. Yes, and then let's see how we simplify this. We're going to have 10m squared plus 10 squared over, and here we can write 1 minus 2m, all of that square to a half. Doesn't really matter the sign inside, and then all of this to the power of a half. So here we're going to have 10 times m squared plus 1 to the power of a half, and then here we have that, well actually shouldn't switch it. We know that 2m minus 1 is greater than 0 because we know that m is greater than half, so we can write over here 2m minus 1. We just afterwards squaring and taking the square root of that. So we need to multiply by that. 10 times 1 plus m squared to the power of half over 2m minus 1. So this is for the area. We are going to have 50, 10 times 10 divided by 2, and then we have 1 plus m squared, and then in the denominator 2 plus m over 2m minus 1. So this is the area of the triangle depending on the parameter m, knowing also that m is greater than half. And we need to know what is the value of m that minimizes this area. So now is when we come to the optimization part of this question. So we want to find the minimum of the function we found for the area depending on m for m greater than half. This is a paper 2 question, so you can use a calculator and you can graph the function, and you will see that the minimum for this function for m greater than half occurs with when m is equal to 3. And that's exactly what we want for our answer. We wanted to find the value of m for which the area of the triangle is a minimum. I made a mistake when simplifying, so I'm going back. This happened in minute 7:30, I believe. I'm here at this point. This actually here, and this equal sign over here should have written 10 square, and then it's correct that in the next step it's just 10 because I took the square root of that.